Hi friends, I am Vinay Raj, studying 8th Sem Mechanical Engineering in Ballari Institution of Technology and Management. I am here to do seminar on the topic honeycomb structures. I am very much embedded to our head of the department, Dr. W. Basuraj sir, and Dr. K. Raghavendra Joshi sir, for their encouragement and moral support. And I am very much thankful to the seminar coordinator, Dr. Raghavendra Kodi sir, for their guidance and valuable suggestions given to me in completion of the seminar. And I also thank my teaching and non-teaching staffs for giving their valuable suggestions in development of my seminar. And first on the PPT, the first slide is content, in this we can see introduction, history, objectives and methodologies, honeycomb composites, geometric type honeycomb structures, applications, advantages, disadvantages, future developments and conclusions. Firstly, it comes to introduction. What is a honeycomb structure? Honeycomb structures are natural or man-made structures. It have the geometry of the honeycomb to allow the minimization of the amount of used materials to reach minimal weight and minimal material cost. The geometry of honeycomb structures can vary widely, but the common feature of all such structures is a hollow shell formed between thin vertical walls. The cells are often columnar and hexagonal in shape. This means that the most of the honeycomb structures are hexagonal in shape, and by these man-made honeycomb structures, they are used in such a way that their weight should be less and the material cost is minimal. And next comes this is the picture of a honeycomb structure. And next comes the history of the honeycomb structures. The three traditional honeycomb production techniques are expansion, corrugation, and molding, which were developed in 1901 for the non-sandwich applications. For decorative applications, the expanded honeycomb production reached a remarkable degree of automation in the first decade of the 20th century. Today, honeycomb cores are manufactured via the expansion process and corrugation process from composite materials such as glass reinforcement plastic, carbon fiber reinforcement plastic, name and paper reinforcement plastic, etc. And next, this is the design of the honeycomb structure. In this we can see the length, width, thickness and even the gap present between the holes of the honeycomb structure. And the thickness should be 2 mm, the gap should be 28 mm, length 133 mm and width 96 mm. Next, there are objectives and methodology. Literature review related to the seminar. Collection of material properties and constraints. Using CATIA V5 software, tool 3D model has been prepared. Finite element model has been created using hypermesh tool. Finite element analysis have been carried out by using LS Dyna tool. Finite element analysis results have been viewed by using LS Prepost tool. Next comes the honeycomb composites. There are two types. One figure represents the man-made honeycomb structures, and another figure represents the natural honeycomb structures. Firstly, natural honeycomb structures occurs in many different environments, from beehives to honeycomb weathering in rocks. Based on these, man-made honeycomb structures have been built with similar geometry to allow the reduction of the quantity of material used, and thereby realizing minimal weight and material cost. In this also we can tell that with man-made honeycomb structures we can reduce the weight and also the material cost. Next comes geometric types honeycomb structures. In geometry, a honeycomb is a space filling or close packing of polyhedral or high dimensional cells so that there is no gaps. It is an example of the more general mathematical tiling in any number of dimensions. Honeycomb are usually constructed in ordinary flat spaces. Types of honeycomb structures are depend upon the geometrical shapes. These different type of honeycomb core structures are like a square, hexagonal, pentagonal, tetrahedral, pyramidal, etc. And the given figure is a hexagonal type of honeycomb structure. And next comes the applications of honeycomb structures. The honeycomb structures are mainly used in sports industries, aerospace industries, light industries, sound industries, automobile industries. Firstly, in sports industries, they are used as racing shells, snowboards. In aerospace industries, they are used as gliders, helicopters, jet aircrafts, rocket substructures, and in light industries, they are used as LED technologies. In sound industry, they are used as loudspeaker technology and telescope mirror structures, and they are used also to prepare the furnitures. And next comes the advantages of honeycomb structures. The honeycomb structures are excellent impact resistance. They are easy color ability. They are tough yet flexible, and their density is low, and they are light in weight, and the shrinkage is very low, and easy forming and processing takes place in this honeycomb structures, and recyclable for in process scrap reuse. We can reuse the material after it gets scrapped, and excellent melt strength and process ability. Next comes disadvantages. Then the high cost of raw materials. The raw material used for preparation of this material is very high. General inability to load, and the high honeycomb structures are poor chemical and high resistance. Their compression set is high and thermal stability is low, and the creep behavior in extended use, and the soften or melt at elevated temperature above which they lose their rubbery behavior. Next, by this we will conclude that the deflection is decreasing as the thickness of the faceplate and thickness of the core wall of the honeycomb structure is increasing. Load carrying capacity of core is increasing as the thickness of faceplate and the thickness of core wall of honeycomb structure is increasing. The stress is decreasing as the thickness of faceplate and thickness of core walls of honeycomb structures are increasing. Next comes to future scope. Future. The finite element analysis and theoretically calculations of a deflection and critical load of the honeycomb structures is carried out for different core materials and for different thicknesses of faceplate and core walls. The thickness wall faceplate can kept constant, and only the thickness of core wall can be changed to study the behavior of the honeycomb sandwich structures. The analysis can be carried out for the different diameters of core cells and also by varying the height of the core of honeycomb sandwich structures for the same combination of materials. This is the figure which shows the meshing process in honeycomb structure. There is the two plates, top plate and base plate, and a honeycomb core is present, and honeycomb core is placed in between the top plate and the base plate, and by this the process takes place. This is the aluminum honeycomb panel lamination. In this there are three main parts. First, the top part, facing skin. After the facing skin, there is next part called adhesive. After adhesive, it comes the structure, honeycomb structures, honeycomb material. After the honeycomb material, down comes the aluminum honeycomb core. And by this the process takes place. This is the figure of aluminum honeycomb panel lamination. Thank you.